Okay, so good afternoon, everybody. Today I'm going to talk about how big data is powering the Internet of Things revolution and about a little bit about who I am. So I'm from Tegucigalpa, Honduras. I have been living in Atlanta for the last 5 years, and you can see we are just 3 hours and a half away from my hometown in a flight. And I have a computer science major with a master in analytics from Georgia State. And currently, I'm a data integration developer in Use Analytics. So I'm working on creating all the data pipelines for our clients. So I have been working a lot with AWS and Spark. Between my hobbies, I have been practicing yoga for the last 10 years. And I like to travel with my husband and to go to the movies. I'm pretty nice fan of Star Wars and Marvel movies. You know, there is a lot of them. So where I work for Use Analytics, and we are a team of visualization experts that we turn your reports and dashboards into an interactive data story. So if you want to know more about us, you can go to useanalytics.com, and you will find also we have a public app that you can see the link over there. That's DEMS2020 useboxdata.com, and you will find that one is something that we just did for the Democratic Party. So we put together all the tweets from them, and we are seeing how they are doing on the current election. So an overview of what I'm going to talk today is what is the Internet of Things and the benefits, what is Internet of Things analytics and its challenges, the IoT analytics in the cloud, some of the landscape, the IoT edge analytics, and a little bit of a demo with a use case about indoor air quality monitoring. So we will see a little bit of that with using Spark. So last year, IoT devices outnumbered the world's population for the first time. And we are seeing that by 2020, we're going to have about 150 million cars that will be connected to the Wi-Fi, and they will be sending data. And we're going to have more than 24 billion of interconnected devices. That means more than 4 devices per person. Also, when you finish reading this, you're going to have like 3,800 new devices connected to the internet. And by 2021, I think Gartner is predicting that 1 million new IoT devices are going to be purchased every hour. So you can imagine that we are going to need to analyze and react to the IoT data simultaneously in real time. But what is Internet of Things? So the Internet of Things is not just about connecting computers and phones, but many objects and spaces to the internet. And they are enabling remote data gathering and interaction. So a thing in the Internet of Things can be a person with a heart monitor implant, can be a farm animal with a biochip, or can be a car with multiple sensors in it that will tell you if your tire pressure is low, for example. Or it can be any object that you can assign to an IP address and is able to transfer data over the network. And what are the benefits of the Internet of Things? Well, they have a number of benefits for the organizations. They basically enable them to monitor their business process. So for example, in manufacturing, you will have sensors that can collect data and can alert you when machines, for example, need to be maintained, or when you need to replace a part. So it can prevent equipment failure. It also helps you to improve the customer experience. So for example, John Deere will use the IoT in many different ways to offer new and innovative products and services to their customers. It can save you time and money. You know, UPS has been using onboard data gathering sensors, so they can optimize the driver's routes. Also, we can make real-time decision making. For example, a bank can automatically verify a new transaction and deny it if it suspects that it's fraudulent. Also, you can generate more revenue. For example, Google Nest. They are collecting real-time energy usage data from consumers, and they are selling this data to utility companies or other third parties. But in order to attain the full potential of the IoT, we need to collect and analyze all this data that is being generated by all these devices. And this is where IoT analytics comes into play, and they are providing the tools and procedures that you need to get value from this data. Some of the challenges are, for example, the data volume. So IoT data sources, all these devices, are producing very large volumes of data and really high ingestion rates. So this typically exceeds the storage and the processing that a typical machine will give you. We also have problems with time. IoT devices are all across the globe sometimes, and events that happen at the absolute same time, they don't necessarily happen at the same local time. So you can have a device on Eastern time and the other one on Pacific time. But they are both of them happening at the same absolute time. But this can affect the integrity of your resulting analytics. Also, we have problems with time and with space, and these devices are in multiple geographic locations. And we have different environmental conditions. So for example, temperature variations can affect your sensor accuracy. Elevation can affect, for example, diesel engines. And remote locations can have a weaker network access to it. And last but not least, we have data quality. So you can have either missing or inconsistent data due to dead batteries or really poor bandwidth. And we will see later how you can find this in your data. But to overcome some of these challenges, we need something that scales quickly, that is dynamic and responsive, and that has a virtually unlimited capacity. And that's why cloud is really the perfect fit for IoT analytics. And some of the advantage you can see there, the speed, you can bring cloud resources online in minutes. The agility is you can create and destroy resources, so you can experiment with them. You have a variety of services, so you have a lot of services available for you to create all the workflows that you need. You have a global reach, so you can start with a solution that is going to have devices in the United States, and then you can extend it to another country in Europe or Africa or wherever you want. And cost control, because you can pay for the resources you need at the time that you need them. So you just pay for what you use. And we can see here, these are the 3 biggest players in cloud right now, and some of the architecture and the services that they're using for IoT. So you can see Google Cloud, they have their own Google Publisher subscriber solution. They have data flow for doing the data pipeline, BigQuery, their data warehouse, and Data Studio for visualization. The same with Microsoft Azure. They have an events hub, that is the one that will be receiving all this data, Stream Analytics to doing the whole processing, Azure Cosmos, there is their data warehouse, and Power BI, their visualization tool. And for AWS, we have Kinesis streaming for just getting all this data, consuming it, Kinesis Analytics for doing the processing, and you can save it into S3 or DynamoDB, or you can use also Redshift if you want, that is their data warehouse solution, and Amazon QuickSight for the presentation side. And AWS recently has launched a really specialized services, so you now have like IoT, real specific services like Greengrass, you have IoT analytics, so they have a really complete suite that you can use and you can start doing something in minutes. Additionally, we have what is called Edge Analytics. So far, the landscape I show you and everything is the normal architecture where you will send all your data directly from IoT devices to the cloud. But for Edge Analytics, you can process your data nearby or in the same source or your device. So you can filter out the data you don't need and send only what you want to the cloud instead of all of it. So one of the benefits is that will help you on reducing storage and processing costs in the cloud. And it also, IoT Edge Analytics usually is applicable, for example, on oil rigs, mines, and factories, where you have a really low bandwidth and low latency environments. So that's where it is really useful. And we're going to look at a really small use case that it has to do with indoor air quality monitoring. So let's start with it. So imagine that we have a company that has deployed thousands of devices around the world, and they want to check on the air quality inside their warehouses. So each device, it has integrated sensors that measure temperature, humidity, and CO2 or carbon dioxide. So these measures, it will help them to get an idea if the warehouse has like the ideal environment for their employees, so they can improve productivity and they can reduce like sick leaves, for example. And this company had spent a lot of money in setting up the infrastructure and getting data from all these devices. However, this data has been piling up in their cloud storage, and it has been costing them like thousands of dollars per month. So we're going to start doing like a small analysis or what we can do with this data. So for an analysis, we want to answer 3 questions. What is the highest temperature during the month of May per country? So we already have historical data about May. And why May? Because it's the latest month that is complete right now. Then which devices have a low battery level and need replacement soon? So you need to know this in order to change the batteries and keep sending data about your warehouses. So it's really important for the business to know it. And lastly, which countries are showing the highest CO2 level in the last 2 hours? So we want to keep a little bit of record about if our CO2 levels inside the warehouses are too high, and we need to make adjustments to reduce them. Okay. And this is the architecture for the demo. Basically, I have the producers, my devices, that I'm going to use a Python program just to create all this data. And for collection, it can be an MQTT or HTTP protocol. And for example, for ingestion, I'm going to use Amazon Kinesis. And then all that data is going to be stored on S3. And the whole processing of the data is going to be with Spark. And you see we have different solutions using Spark Streaming, SQL, and normal data frames. And for presentation, Databricks Notebook. So all these will be running on Databricks and AWS on the back. So the first part, producing and sending data to the cloud, I will show you what I did for that. So I created a list of a number of devices that are like in a dictionary. And then I'm using this library called Faker. So with Faker, you can create like fake objects. They provide some things like for creating fake addresses or fake names. But basically, I create one just for my devices. So I take the information for the device, the static information like device ID, device name, IP address, the country, latitude, longitude, and then for the measures like temperature, humidity, battery level, I basically take one value from that one I add or subtract like an offset, so I can maintain almost the same temperature and there is not that much variation on it. So we will go back to our presentation, and that code will send data to my Kinesis stream. So moving on with the part of ingestion and storage, I'm using Amazon Kinesis, and I will show you over here as well what I'm doing. So basically, I'm using, I'm defining a data stream that is called IoT data, and then I'm using Kinesis Firehouse to basically tell it to receive that data, to collect it, and then after 1 megabyte or 60 seconds, send it as a log to S3. And you can see over here on S3, we have data that is being generated every minute. So moving on, we have the last part that is data analytics and visualization. And this part I'm going to show you a notebook over here. So this is created on Databricks. And you can, it looks pretty like a normal Jupyter notebook. So it's pretty useful when you want to show things and create tutorials or that kind of stuff. So continuing with our indoor air quality monitoring app, we have over here the data description. So you can see we have a device ID, device name, we have some information about the country. It can be 2-letter, 3-letter codes, and the country, the whole country name. And we have latitude, longitude, the scale of the temperature is in Fahrenheit. And we also have the event time. So this is when the event happened, when our device make the measure and send it to the cloud. So the usual process is to start, for example, doing some batch processing at first, and you might want to do that for 2 reasons. The first one is you want to create your analysis on streaming, but you also want to do several iterations over it, and you want to see how the data is going to look like. So you can do batch processing. Also, when you don't need to have like real-time data or do an analysis that needs like an immediate response, you can do batch processing. And in this case, we're going to do it over our historical data for May. So you can see we have a lot of files over here for May. And one of the main challenges is you have a really lot of big files, and it's impossible for you just to open it in a tool like Excel, for example. And that will become really difficult. You won't be able to do anything with this data. So that's why we are using tools like Spark that it will give you the ability to read and manipulate this data. And you can see over here, it's pretty simple just to read data. You just use a spark.read. You tell it to infer the schema, and then I'm telling it just we are reading JSON files, and we give it like the input, like where is my data, the path. We can catch what is going to create is a data frame, and we can catch the data frame, so we improve performance. And finally, we're going to create a view. So this view, we can use it later just to use a Spark SQL and do normal queries over it. You can see here, this is a sample of this data. So you have different measures over here. Temperature is on Fahrenheit. And we also have humidity. And for example, this LCD, this is like a display that will show you whether the CO level is good, is kind of on warning, or red. So if it is less than 1,000, it will be on green. If it is between 1,000 and 1,400, it will be yellow. And if it is more than 1,400, it will be red. But also, do the nature of these low-power sensors and all the unreliable connectivity that we have, especially if they are in really remote zones, we can have a lot of missing and incomplete data. So in this case, you might want to check, for example, for data continuity. So what you can do is just to see how many records you have per device per day. And in this case, this data is aggregated per hour. So you have to have like 24 records for each of them. In some cases here, I will have like 22. So that tells me that either my device has a connectivity problem, and I need to go and see all the historical data to see if this is a pattern or was just a one-time event. And we can also check, for example, if we have some peaks on the record count. So you can use, for example, describe to see the count of records. We can see all of them have the same count of records, so we are fine over there. And you can also look at the minimum and maximum values for each. And from there, you can see the battery level goes from 0 to 9. 0 is non-level at all, and 9 is when it's full. And then we can see the values of CO level. And for example, for humidity, if you see here, it's going above 100, and that's not that it shouldn't be. So you know that is an abnormal value, and you need to go back to your data and check what happened over there. And the same with temperature. We have a really high temperature. 108 is too high for being inside a warehouse. So you need to see if your device is faulty or we are not following the procedures inside the warehouse. And you can do some analysis like just taking one specific device and seeing if everything looks normal over there. Like taking temperature and humidity, you don't see any big variations over there. They are almost inside that range, so that's fine. But well, getting back to our questions, we want to answer what is the highest temperature during the month of May per country. So high temperatures have like a number of adverse effects on the human body. So it can contribute, to low energy and like feeling lethargic. So we really want to know if we are not following the rules over here at keeping a cool environment into our warehouses. So as you see here, we're going to do a group by country, and we're going to group it per day. And then we're going to get the max temperature and max humidity per country. Again, we are catching this data frame just to improve the performance. And then we are creating a view so we can use a Spark SQL to do a normal query like the ones you do in your database. We can see when I do the query over here, if you see this is a normal query using SQL. And you can see we have, for example, the normal temperature that you should have inside your warehouse is between 60 and 76, at most 80. And you see that we have a lot of countries over there with more than 90. And this one here, the Philippines, that just go over it and has a really high variation. So you need to check either your device and see if it is faulty, or see if just is the real temperature in the warehouse. And we are just having employees who are dying of the really hot temperature over here. But this is something you can do to see pretty quick what is happening, okay? And the other ones, they're showing pretty normal temperatures inside that range. So once we have the answer to that, we can move to what is streaming processing. So streaming is usually a series of events. They don't have an end. They will continuously send data to a stream processing system, in this case, Spark. And what is the difference between having batch processing and streaming processing? Well, on batch processing, you can execute a SQL, and basically will execute once, and it will happen over a fixed data set. On a streaming, it will continuously executing. Just the more data you have, it will continue trying to update these SQL data set results, and it will indefinitely be running over there. And you can see that we can read a data stream pretty easy. So basically, instead of using read, like we did on batch processing, we are using read stream. So you can change the query or every code that you have at the beginning for a read stream, and everything will be the same afterwards. So it's pretty easy. And you can test whether you have a streaming data frame with this call that is streaming. And over here, you can see that it's a stream. So we right now have a streaming running over there. And right now, I have a lot of data being sent to here. And you can see we have an input versus processing rate. So the input rate usually is all the data flow that we are getting into our stream, and the processing rate is the one how much or how long it's taking for us to process this data. And you can see we have some peaks over here. That is why I show you that on S3 is being sent every minute. So all these peaks mean that every minute is reading like a bunch of records from S3. So this is happening every minute. And you can see the processing rate is pretty low over here. So when there is a big difference between your input and your processing rate, it means that you need to add more resources to your cluster so you can process them more faster. And you can see we are getting data over here. And And this, basically, the way that a stream works is like a table, and you will be adding data continuously to this table. So it will increase and increase continuously. So let's move to our second question and see how we can answer that with streaming. So our second question is, which devices have a low battery level and need replacement soon? So we are going to get first like the latest record for each device, so we can get the current battery level. And it's really important that we know what is the difference between an event time and a receive time. Because event time is when your device it takes the measure of temperature or humidity, and receive time is the time when your data was collected in the cloud. So they're pretty different, and they can be like a difference of minutes or hours depending on the bandwidth and depending on the connectivity. So it depends if accuracy is really important for you, then you need to take in account like the event type, not the receive time, okay? So in this one, we have the same. We're doing a group by device, and we are taking the maximum day, so the latest event. And you can see here, we have the latest event. We have readings from 7 minutes ago. So every time it enters a new reading, it will be updating all this information. And I have over here my device ID and my device name. And this will keep updating. So we can have these streams get written even to a database. But in this case, I'm reading them to memory. So I can show you how to do all the Spark SQL over them. But you can do your analysis and just write them to a S3 bucket, or for example, a normal database like Redshift, and you can write them in JSON file as a bucket of Avro or whatever file that you want to. So I'm creating these queries. You see I'm giving it a name. And for example, when I have data frames where I haven't done any aggregation, I can do just an append. But when I have data frames where I have been doing aggregations, I need to do a complete, because it has to wait for the whole aggregation to finish up to put it inside the stream. So for example, you can see if I do a normal SQL query, taking like the last event time for each device, and we take, for example, battery level from 0 to 2. 0 means non-battery. And 1 and 2 will be really low battery levels. You can see that, for example, we have on United States, we have 3 devices that has 2 battery levels and 3 devices with 1. And we definitely have 1, or no, over here. We have 3 that it definitely run out of batteries. So for example, this kind of visualizations, you can choose to put it for your manager, for example, who wants to create like processes, all kind of things to see how can we more proactive about replacing these batteries. But then when you want to go with the people who really know and really need to replace these batteries, then you need to create like a table where you're going to tell them what is the battery level so they can prioritize, and then see which device is the one that needs to be replaced. And finally, we can answer which countries are showing the highest CO2 level in the last 2 hours. So, for example, one of the main problems of aggregating the entire data set is that it doesn't have an end. So, if you keep trying to aggregate the whole information in your stream, you will finally run out of resources. And that, or you will have to be scaling, and that's more money for you. So we can group this data into windows of time, and that can be minutes, that can be hours or days. So in this case, we're going to group it in 2 hours. So you can see, for example, over here, that we already have like 2 windows for each device. One is from 12 to 2, the other is from 2 to 4. And the last time it received like a reading from that specific device was at 3, like 5 minutes ago. So this is running in real time, and you can see how the data is being updated. And we also create for this one like a query, and we tell them to the open mode to have complete. So all the counts, all the aggregation should be in the table before showing it. So over here, for the last window of time that it goes from 2 to 4 p.m., we have like how many devices out of the 100 that I have. They have, for example, LCD of yellow. This means that my CO level is on warning state, that is between 1,000 and 400. And we have 28 that are on red. This means that these ones are going beyond the normal CO levels. And the last one, we have 24 out of 100 that are good. So we don't need to worry about them. So again, this is the kind of graphic that you can show really to your manager or everybody really high up that can see a really overview of what's happening with all the devices across the world. And finally, we want to see which is the country that has the highest levels. So in this case, we can filter, for example, the LCD on red, because we are interested only on the highest levels of CO2. And you can see over here, the United States, we have like 9 devices that are really pretty high levels. And they're followed by Canada or Russia or India with 1 device on each. And finally, you can see, for example, which streams you have active. And you can use the Spark Streams Active, and it will show up over here which are the queries that are active. And you can stop all of them at the same time if you want to. But this is running in real time, so in production, you can't just stop it. And finally, we really want to decide if you really need real-time streaming over the historical batch processing. So for example, streaming is really helpful if you have sensor data that can tell you like right away if there is a problem, for example, with equipment failure, or there is an oil leakage, and you need to take measures really quickly and in real time. So if you only want to get like new insights or new business opportunities, you can pretty much continue using batch processing instead. And in that way, you are not going to incur with extra costs in processing and storage. And finally, this is all I have for you. So if you have any questions, just let me know. I hope you're having a great time on the conference. You keep enjoying the last hours. So.
About the CO2 level, you choose just 3 different colors. So why did you don't show the real numbers? Because it's a measurement of CO2 level is on, I don't know, between 400 until 2000 something. So why you don't show the real number?
Well, for the demo, I didn't choose it because I didn't have more time. But for example, you want to go first to the really generalized. So you group it into 3 sessions. And then if you want to focus just, for example, in really high levels or the warning ones, you can create like a query that tells you really specific which ones are the ones with the CO2 level really high and the values of it. So you can go into the detail of them.
So from the device, it's going not about from 3 numbers, but it's the real number.
Yeah, it's a real number, but the LCD was only used to group them into 3 categories. So
it's processed in the LCD?
yes, but they have 2 different fields. So you will have your field when you have the number, and I can show you here. So over here, you can see that you have the number.
So you are sending both?
Yes, so I'm using both. I'm not showing all both, but I have the number over there. So you can go into the detail later on if you want to. Okay.
Is there a specific source of data that you are using to get this from, or is this scraping, or like how do you?
So for this one, yes, I took the initial data set from Databricks example, and then the data that you are seeing right now is being generated in real time. So with the faker object.
Yeah, what I meant like in real scenario, how do you guys like use analytics?
No, yes, yeah, this is just like a fake demo, so. More questions? Okay, thank you for coming then. Have a nice day.